Lecture 15, Security Risk Management. Theme: Risk Management, Policies, and Compliance. Technical University of Moldova. Lecturer: Maxim Masiyutin, Associate Professor. Introduction. Welcome to Lecture 15, everyone. Today we explore security risk management, the systematic process of identifying, assessing, and treating security risks. This is one of the most important topics in our course because risk management drives all security decisions. Every control we implement, every policy we write, every tool we deploy should be justified by the risks it addresses. Let me begin with a fundamental truth. We cannot eliminate all risk. Security resources are finite, threats are unlimited, and perfect security would make systems unusable. Our goal is not to eliminate risk, but to manage it, to reduce risk to acceptable levels while enabling the organization to achieve its objectives. Risk management answers essential questions. What could go wrong? How likely is it? How bad would it be? What should we do about it? Is our response proportionate to the risk? Organizations that practice mature risk management make better security decisions. They invest where it matters most. They avoid both underprotection and overprotection. They can justify their security programs to leadership and regulators. Over the next 2 hours, we will cover the risk management lifecycle, assessment methodologies, asset and threat analysis, risk calculation, treatment options, and frameworks, including ISO 27005. We will also discuss the growing challenges of third-party risk and the role of cyber insurance. Part 1. The Risk Management Lifecycle. Understanding risk. Before diving into process, let us define key terms precisely. Risk is the potential for loss or harm when a threat exploits a vulnerability. Risk has 2 dimensions: likelihood and impact. A high likelihood, high impact event represents high risk. A low likelihood, low impact event represents low risk. A threat is anything that could cause harm: a natural disaster, a malicious actor, an accidental action, a system failure. Threats exist whether or not we can control them. A vulnerability is a weakness that a threat could exploit. Vulnerabilities exist in technology, processes, and people. An unpatched server is a technical vulnerability. A lack of access reviews is a process vulnerability. An untrained employee is a human vulnerability. An asset is something of value we want to protect. Assets include data, systems, people, reputation, and physical property. A control is a safeguard or countermeasure that reduces risk by preventing threats, reducing vulnerabilities, or limiting impact. The lifecycle phases. Risk management is not a one-time activity, but a continuous cycle. The life cycle has several phases. Phase 1. Context establishment defines the scope and criteria for risk management. What assets are we protecting? What is the organization's risk appetite? What regulatory and business requirements apply? Phase 2. Risk identification systematically identifies assets, threats, vulnerabilities, and existing controls. We ask, what do we have? What could threaten it? What weaknesses exist? Phase 3. Risk analysis determines the likelihood and impact of identified risks. This can be qualitative, high, medium, or low, quantitative, numerical, or semi-quantitative, combining both approaches. Phase 4. Risk evaluation compares analyzed risks against criteria to determine which require treatment. Not all risks need action. Some are acceptable. Phase 5. Risk treatment selects and implements controls to modify risk. Options include avoiding, mitigating, transferring, or accepting risk. Phase 6. Monitoring and review tracks changes in the risk landscape, verifies control effectiveness, and triggers reassessment when needed. Communication and consultation occurs throughout all phases. Stakeholders must understand risks and participate in decisions. Integration with business processes. Risk management should not exist in isolation. It integrates with strategic planning, project management, change management, and daily operations. Security risk management is a subset of enterprise risk management. Organizations face financial risks, operational risks, strategic risks, and compliance risks alongside security risks. Mature organizations manage all risks through integrated frameworks. At the board level, security risk is increasingly a topic of discussion. Regulatory requirements in 2025 and 2026, including SEC rules in the United States and DORA in Europe, require boards to oversee cybersecurity risk. Security leaders must communicate risk in business terms, not technical jargon. Part 2. Risk Assessment Methodologies. Qualitative Risk Assessment. Qualitative assessment uses descriptive categories rather than numbers. Risks are rated as high, medium, or low based on judgment rather than calculation. A typical qualitative approach uses a risk matrix. One axis represents likelihood, rare, unlikely, possible, likely, almost certain. The other axis represents impact, insignificant, minor, moderate, major, catastrophic. The intersection determines risk level. Advantages of qualitative assessment include simplicity and speed. It does not require precise data on frequencies or costs. It is accessible to non-technical stakeholders. Disadvantages include subjectivity and imprecision. Two assessors may rate the same risk differently. Comparing risks across categories is difficult. Justifying specific investments is challenging when risks are described only as high or medium. Quantitative risk assessment. Quantitative assessment assigns numerical values to risk components. It calculates risk as annual loss expectancy, ALE, equals single loss expectancy, SLE, x annual rate of occurrence, ARO. Single loss expectancy is the cost of a single incident. Annual rate of occurrence is how many times per year we expect the incident to occur. Annual loss expectancy is the expected cost per year. For example, a data breach might cost $5 million SLE. Based on industry data and our controls, we estimate a 10% chance of occurrence per year, ARO equals 0.1. YELE equals 5 million x 0.1 is equal to $500,000 per year. This allows direct comparison with control costs. If a control costs $200,000 per year and reduces ALE from $500,000 to $100,000, the control provides net benefit of $200,000, $400,000 reduction minus $200,000 cost. Advantages of quantitative assessment include precision and comparability. It supports financial decision-making and ROI calculations. Disadvantages include data requirements and false precision. Accurate SLE and ARO values require historical data that may not exist. Calculated values appear more certain than they are. The 2024 IBM cost of a data breach report provides useful benchmarks. The average breach cost was $4.88 million, but individual incidents varied dramatically. Semi-quantitative and hybrid approaches. Most organizations use hybrid approaches. They apply qualitative methods for initial screening and reserve quantitative analysis for high-priority risks where data exists and investment decisions require justification. FAIR, Factor Analysis of Information Risk, is a popular semi-quantitative framework. FAIR decomposes risk into loss event frequency and loss magnitude, then further decomposes each factor. It produces probabilistic ranges rather than point estimates, acknowledging uncertainty. The FAIR Institute, established in 2016, has grown significantly. Major organizations, including many Fortune 500 companies, use FAIR for risk quantification. FAIR is now an international standard, open FAIR. Part 3. Asset Identification and Classification. Why assets matter. You cannot protect what you do not know you have. Asset identification creates the foundation for risk management by establishing what requires protection. Many organizations discovered during assessments that they have unknown assets, shadow IT systems deployed by business units, forgotten servers running in closets, data stored in unauthorized locations. Each unknown asset is an unknown risk. Asset categories. Information assets include data in all forms: customer records, intellectual property, financial data, operational data, employee information. Data is often the most valuable and most targeted asset type. Technology assets include hardware, software, and networks, servers, workstations, mobile devices, applications, databases, network equipment. Technology assets process and store information assets. Physical assets include facilities, equipment, and physical security systems. data centers, offices, access control systems, surveillance equipment. Human assets are the people who operate systems and make decisions. Employees, contractors, partners with system access. People are both assets to protect and potential vulnerabilities. Intangible assets include reputation, brand, customer trust, and regulatory standing. These can be damaged by security incidents even when no data is lost. Asset inventory. Maintaining accurate asset inventory is challenging but essential. Manual inventories become outdated quickly. Automated discovery tools help, but have limitations. For technology assets, use automated discovery scanning to identify devices and systems. Configuration management databases, CMDBs, should track asset relationships and ownership. Cloud environments require specific tools as assets can be created and destroyed rapidly. For data assets, data classification tools and data loss prevention systems help identify where sensitive data resides. Data mapping exercises trace data flows through systems. For all assets, assign ownership. Every asset should have a designated owner responsible for its protection. Ownership enables accountability for risk decisions. Asset classification. Classification assigns sensitivity or criticality levels to assets. Common classification schemes include confidentiality classification, public, internal, confidential, restricted. This drives access controls and handling procedures. Criticality classification, low, medium, high, critical. This drives availability requirements and recovery priorities. Regulatory classification identifies data subject to specific regulations. Personal data under GDPR, payment card data under PCI DSS, health information under HIPAA. Classification should be practical. Too many categories create confusion. Classification should be verifiable and enforceable. Tag data and systems with classification labels. Automate enforcement where possible. Part 4. Threat modeling. The purpose of threat modeling. Threat modeling systematically identifies how attackers might compromise systems. It shifts thinking from what could go wrong to how would an attacker approach this. Threat modeling is valuable during design, before systems are built. It is also valuable for existing systems to identify overlooked risks. It creates a common understanding between security teams, developers, and operations. STRIDE Threat Model. STRIDE is a threat categorization model developed at Microsoft. The acronym represents 6 threat categories. Spoofing involves pretending to be something or someone else. An attacker spoofs a user identity to gain unauthorized access. An attacker spoofs a server to conduct man-in-the-middle attacks. Tampering involves modifying data or code without authorization. An attacker tampers with database records. An attacker modifies executable code to inject malware. Repudiation involves denying having performed an action. A user denies making a transaction. An attacker deletes logs to hide their activities. Information disclosure involves exposing information to unauthorized parties. Sensitive data is exposed through improper access controls. Data is leaked through side channels or error messages. Denial of service involves making systems unavailable. Attackers consume resources to prevent legitimate use. Systems are crashed through malicious input. Elevation of privilege involves gaining capabilities beyond those authorized. An attacker escalates from user to administrator. A contained process escapes its sandbox. For each system component, consider which STRIDE categories apply. For each applicable category, identify specific attack scenarios. For each scenario, identify potential controls. PASTA Threat Modeling. PASTA, Process for Attack Simulation and Threat Analysis, is a 7-stage risk-centric threat modeling methodology. Stage 1. Define objectives, establishes business objectives and security requirements. What are we protecting and why? Stage 2. Define technical scope, documents the technical environment, architecture, technologies, data flows, and trust boundaries. Stage 3. Application decomposition, breaks down the application into components, identifying entry points, assets, and trust levels. Stage 4. Threat analysis, identifies threat actors, their capabilities, and their motivations. Who might attack and why? Stage 5. Vulnerability analysis identifies weaknesses that threats could exploit using vulnerability scanning, code review, and architecture analysis. Stage 6. Attack modeling builds attack trees showing paths attackers might take. This models the attacker's perspective. Stage 7. Risk and impact analysis assesses the business impact of successful attacks and prioritizes responses. PASTA is more comprehensive than STRIDE, but requires more effort. It is particularly valuable for critical applications where thorough analysis is justified. Threat intelligence integration. Threat modeling benefits from threat intelligence, information about real-world threats, attackers, and their techniques. Tactical intelligence describes specific indicators of compromise, IP addresses, malware hashes, attack patterns. This supports detection and response. Operational intelligence describes attacker campaigns and techniques. Understanding how attackers operate helps identify relevant threats. Strategic intelligence describes the threat landscape, emerging trends, and attacker motivations. This informs risk priorities and security strategy. Sources include commercial threat intelligence providers, industry sharing organizations, ISACs, government agencies, CISA, NISA, and open source intelligence. The MITRE ATT&CK framework provides a knowledge base of adversary tactics and techniques. Use ATT&CK to ensure threat models consider known attack patterns. Part 5. Vulnerability assessment and penetration testing. Vulnerability assessment. Vulnerability assessment identifies weaknesses in systems that threats could exploit. It answers, where are we vulnerable? Automated vulnerability scanning uses tools to identify known vulnerabilities. Network scanners like Nessus, Qualys, and OpenVS identify missing patches, misconfigurations, and known vulnerabilities in network services. Application scanners identify web application vulnerabilities. Container and cloud scanners address modern infrastructure. Manual vulnerability assessment supplements automation. Some vulnerabilities require human analysis to identify business logic flaws, complex attack chains, context-specific weaknesses. Vulnerability assessment should be continuous. New vulnerabilities are discovered daily. The 2025 vulnerability landscape shows over 30,000 CVs published annually. Point-in-time assessments quickly become outdated. Vulnerability prioritization. Not all vulnerabilities require immediate action. Prioritization focuses effort where it matters most. Factors for prioritization include severity. How exploitable is the vulnerability? How severe is the potential impact? CVSS, Common Vulnerability Scoring System, provides standardized severity ratings. Exposure. Is the vulnerable system internet-facing or internal? Can attackers reach it? Asset criticality. How important is the affected system? A critical vulnerability in a test system differs from the same vulnerability in a production payment system. Exploit availability. Is exploit code publicly available? Active exploitation in the wild increases urgency. Compensating controls. Do other controls reduce the effective risk? A vulnerable system behind multiple security layers differs from one directly exposed. SSVC, Stakeholder-Specific Vulnerability Categorization, from CISA provides decision trees for prioritization based on exploitation status, technical impact, and mission impact. Penetration testing. Penetration testing goes beyond vulnerability assessment to actually exploit vulnerabilities. Testers simulate real attackers to demonstrate what an attacker could achieve. External penetration testing attacks the organization from the internet, as an external attacker would. Internal penetration testing assumes the attacker has gained internal network access, testing what they could achieve from inside. Application penetration testing focuses on specific applications, attempting to compromise application logic, data, and underlying systems. Social engineering testing tests human vulnerabilities through phishing, phone pretexting, or physical intrusion attempts. Red team exercises are comprehensive simulated attacks testing detection and response, as well as prevention. Red teams operate covertly, measuring how long before defenders detect them. Purple team exercises combine red team attackers with blue team defenders, collaborating to identify weaknesses and improve detection. Testing requirements and standards. Several standards guide penetration testing. PTS, Penetration Testing Execution Standard, provides a framework for test phases from engagement to reporting. OWASP Testing Guide provides comprehensive methodology for web application testing. NIST 800 to 115 provides technical guidance for security testing. PCI DSS requires annual penetration testing for merchants and service providers handling payment cards. Penetration testing should be performed by qualified testers, whether internal or external. Reports should prioritize findings by business risk, not just technical severity. Part 6. Risk Calculation and Treatment Options. Risk Calculation. Risk calculation combines likelihood and impact assessments to determine overall risk levels. In qualitative approaches, combine likelihood and impact categories using a risk matrix. A likely event with major impact is high risk. An unlikely event with minor impact is low risk. In quantitative approaches, calculate ALE equals SLEXARO as discussed earlier. More sophisticated approaches use Monte Carlo simulation to model risk distributions. Risk scores enable comparison. You cannot address all risks simultaneously, so scoring helps prioritize. But remember that scores are estimates, not facts. They should inform decisions, not replace judgment. Risk appetite and tolerance. Risk appetite is the amount of risk an organization is willing to accept in pursuit of objectives. A startup may accept high risk for rapid growth. A hospital may accept very little risk with patient safety. Risk tolerance defines acceptable variation around objectives. A system with 99.9% availability target might have tolerance for occasional drops to 99.5%, but not below 99%. These concepts are set by leadership, not security teams. Security teams advise on risks. Leadership decides what risks are acceptable. Treatment options. When risk exceeds acceptable levels, treatment options exist. Risk avoidance eliminates the risk entirely by not engaging in the risky activity. If a system presents unacceptable risk, you might retire it. If a business function presents unacceptable risk, you might discontinue it. Avoidance is appropriate when costs of mitigation exceed benefits of the activity. Risk mitigation reduces likelihood or impact through controls. Technical controls like firewalls and encryption reduce likelihood. Detective controls like monitoring enable rapid response. Recovery controls like backups reduce impact. Risk transfer shifts risk to another party. Cyber insurance transfers financial risk of incidents. Outsourcing transfers operational risk, though you retain accountability. Contracts may transfer legal liability for specific risks. Risk acceptance consciously decides to accept the risk without further treatment. This is appropriate when risk is within appetite, treatment cost exceeds benefit, or risk cannot be further reduced. Acceptance must be documented and approved by appropriate authority. Control selection. When mitigating risk, select controls based on effectiveness. How much does the control reduce risk? Does it address likelihood, impact, or both? Cost. What are implementation and operating costs? Include direct costs and operational impact. Feasibility. Can the control be implemented and maintained given organizational constraints? Side effects. Does the control introduce new risks or operational friction? Defense in depth principles recommend multiple overlapping controls. If one control fails, others provide protection. Part 7. ISO 27005 Framework. ISO 27005 Overview. ISO 27005 is the international standard for information security risk management. Part of the ISO 27000 family, it provides guidelines for implementing risk management within an information security management system, ISMS, as defined by ISO 27001. The 2022 revision of ISO 27005 aligned with the latest ISO 27001:2022 and incorporated lessons from implementation experience. It remains the definitive guide for risk management in information security contexts. ISO 27005 Process. The standard defines a risk management process with these activities. Context establishment defines scope, boundaries, and organization of risk management. It establishes risk evaluation criteria, impact criteria, and risk acceptance criteria. Risk identification identifies assets, threats, existing controls, vulnerabilities, and potential consequences. The standard provides comprehensive lists for consideration. Risk analysis estimates risk levels. ISO 27005 supports both qualitative and quantitative approaches. It emphasizes considering both likelihood and consequence. Risk evaluation compares estimated risk against criteria. It determines whether risks require treatment and prioritizes treatment. Risk treatment selects treatment options and controls. The standard references ISO 27001 Annex A controls as potential treatments. Risk acceptance formally accepts residual risks. Acceptance decisions must be documented with authorization from appropriate managers. Risk communication ensures relevant information reaches decision-makers and stakeholders throughout the process. Risk monitoring and review continuously monitors risks, controls, and the risk management process itself. Integration with ISO 27001. ISO 27001 requires organizations to define a risk assessment process, perform risk assessments, and implement risk treatment. ISO 27005 provides the detailed guidance for these requirements. The statement of applicability required by ISO 27001 connects directly to risk treatment. It documents which controls are implemented and justifies exclusions based on risk assessment. Organizations seeking ISO 27001 certification typically follow ISO 27005 for risk management, though the standard does not mandate any specific methodology. Practical application. When applying ISO 27005, tailor the process to your organization. The standard provides principles, not rigid procedures. Adapt to your size, industry, and risk environment. Maintain documentation. ISO 27005 requires documenting decisions, assumptions, and results. This enables consistency and supports certification. Review regularly. The standard requires reviewing risks when significant changes occur and at planned intervals. Use available resources. ISO 27005 annexes provide examples and guidance. Industry-specific supplements exist for sectors like healthcare and finance. Part 8. Third-party risk management. The third-party challenge. Modern organizations depend on numerous third parties: cloud providers, software vendors, service providers, business partners. Each third party with access to your data or systems extends your attack surface. Third-party breaches are common and costly. The 2024 and 2025 breach reports show that a significant percentage of breaches involve third parties. Attackers increasingly target the supply chain, compromising one vendor to reach many customers. Regulatory requirements increasingly address third-party risk. GDPR requires controllers to ensure processor security. DORA requires financial institutions to manage ICT third-party risk. Industry standards like PCI DSS include third-party requirements. Third-party risk program components. A comprehensive third-party risk program includes inventory. Know all third parties with access to systems or data. Shadow IT and unauthorized SaaS usage create unknown third-party relationships. Classification. Categorize third parties by risk level based on data access, system access, and criticality. Not all third parties require the same scrutiny. Assessment. Evaluate third-party security before engagement and periodically thereafter. Methods include questionnaires, documentation review, assessments, and continuous monitoring. Contract requirements. Include security requirements in contracts. Address data protection, incident notification, audit rights, and termination provisions. Continuous monitoring. Third-party risk changes over time. Monitor for security incidents, financial distress, and significant changes. Incident response. Plan for third-party incidents. How will you learn of breaches? What are your response procedures? Assessment methods. Security questionnaires gather information about third-party controls. Standardized questionnaires like SIG, Standardized Information Gathering, and CIQ from Cloud Security Alliance enable comparison. Documentation review examines third-party certifications, ISO 27001, SOC2, audit reports, and policies. SOC2 Type 2 reports are particularly valuable as they cover control effectiveness over time. Technical assessment may include vulnerability scanning, penetration testing, or security architecture review for high-risk third parties. On-site assessments physically visit third-party facilities for the highest risk relationships. Continuous monitoring services provide ongoing visibility into third-party security posture, including exposed credentials, vulnerabilities, and breach indicators. Regulatory requirements for third-party risk. DORA, Digital Operational Resilience Act, takes effect in January 2025 and imposes significant requirements on financial institutions for managing ICT third-party risk, including concentration risk and exit strategies. NS2 directive requires managing supply chain security for essential and important entities across multiple sectors. GDPR Article 28 requires data processors to provide sufficient guarantees and requires appropriate contracts. Organizations must understand which regulations apply and ensure third-party programs meet requirements. Part 9. Cyber Insurance. The role of cyber insurance. Cyber insurance transfers financial risk of security incidents to insurers. When incidents occur, insurance can cover costs including incident response, forensic investigation, legal counsel, crisis management, business interruption, lost revenue during outages, data breach costs, notification, credit monitoring, regulatory fines, where insurable, ransom payments, though increasingly restricted or excluded, third-party liability, claims from affected customers or partners. The cyber insurance market 2025 to 2026. The cyber insurance market has matured significantly. Premiums have stabilized after sharp increases in 2021 to 2023 driven by ransomware losses. Insurers have improved their risk assessment capabilities. Key market trends include increased underwriting rigor. Insurers require evidence of specific controls before providing coverage. Multi-factor authentication, endpoint detection, backup practices, and incident response plans are commonly required. Ransomware coverage restrictions. Many policies now exclude or sublimit ransomware payments. Some exclude payment if victims did not have specified controls. Coverage for emerging risks. Policies increasingly address cloud-specific incidents, social engineering, and supply chain attacks. Regulatory developments. Some jurisdictions are considering restrictions on ransom payment reimbursement. Selecting cyber insurance. When selecting cyber insurance, understand your risk profile. What incidents are most likely? What would they cost? Insurance should address significant financial risks. Review policy details carefully. Coverage limits, sublimits, exclusions, and definitions matter enormously. Data breach may be defined narrowly or broadly. Ensure coverage matches your environment. Traditional policies may not adequately cover cloud incidents or third-party breaches. Consider coverage for regulatory costs. GDPR fines can be massive. Understand if your policy covers regulatory actions. Review incident response requirements. Many policies require using insurer-approved vendors. Understand these requirements before incidents occur. Insurance as part of risk management. Insurance is one risk treatment option, not a substitute for security. Insurers expect policyholders to maintain reasonable security. Claims may be denied if misrepresentation occurred during underwriting or if policyholders failed to maintain stated controls. Insurance does not cover all costs. Reputational damage, long-term business impact, and non-financial consequences are not insurable. Insurance should complement, not replace, security investment. Use insurance for residual risk after implementing appropriate controls. Part 10. Building a risk management program. Program elements. An effective risk management program includes governance, clear roles, responsibilities, and authority for risk decisions. A risk committee or designated risk owner provides oversight. Methodology, documented approach to risk identification, assessment, and treatment. Consistent methodology enables comparison over time. Tools, Technology supporting asset inventory, risk assessment, control tracking, and reporting. GRC, governance, risk, and compliance. Platforms consolidate these functions. Processes, regular assessment cycles, exception handling, escalation procedures, and integration with change management. Reporting, regular reporting to leadership on risk status, trends, and treatment progress. Dashboards and metrics enable oversight. Culture, risk-aware culture where employees understand risks and their role in managing them. Common challenges. Organizations often struggle with scope. Trying to assess everything leads to superficial assessments. Prioritize based on asset criticality. Data quality. Risk assessments are only as good as their inputs. Invest in asset inventory and threat intelligence. Integration. Risk management isolated from business processes has limited impact. Integrate with project management, change management, and strategic planning. Stakeholder engagement. Risk management requires input from business units, not just IT. Build relationships and make participation valuable. Action. Assessment without treatment accomplishes nothing. Ensure assessment leads to decisions and action. Maturity development. Risk management maturity develops over time. Initial, ad hoc risk management, reactive responses. Developing, basic processes documented, some consistency. Defined, comprehensive methodology, regular assessments, integration with other processes. Managed, quantitative risk measurement, metrics-driven improvement. Optimizing, continuous improvement, predictive capabilities, risk management embedded in culture. Most organizations operate at developing or defined levels. Advancing maturity requires sustained investment and executive support. Conclusion. Let me summarize the key concepts from today's lecture on security risk management. We began with the risk management lifecycle: context establishment, identification, analysis, evaluation, treatment, and monitoring. Risk management is continuous, not a one-time project. Risk assessment methodologies range from qualitative, high, medium, or low, to quantitative, YELI calculations, to hybrid approaches like FAIR. Choose methods appropriate to your needs and available data. Asset identification and classification create the foundation for risk management. You cannot protect what you do not know you have. Threat modeling with frameworks like STRIDE and PASTA systematically identifies how attackers might compromise systems. Threat intelligence enhances modeling with real-world attack patterns. Vulnerability assessment identifies weaknesses, while penetration testing demonstrates what attackers could actually achieve. Prioritize vulnerabilities based on exploitability, exposure, and asset criticality. Risk calculation combines likelihood and impact. Treatment options include avoidance, mitigation, transfer, and acceptance. Choose based on risk appetite and cost-benefit analysis. ISO 27005 provides the international framework for information security risk management, integrating with ISO 27001 for ISMS implementation. Third-party risk management addresses the extended attack surface from vendors, partners, and service providers. DORA, NS2, and other regulations increasingly mandate third-party risk programs. Cyber insurance transfers financial risk, but does not substitute for security. The market has matured with increased underwriting rigor and ransomware restrictions. For your preparation, consider how you would conduct a risk assessment for an organization you know. Identify key assets, threats, and vulnerabilities. Practice explaining risks in business terms, not technical language. In our next lecture, we will explore security policies and compliance, how organizations codify security requirements and demonstrate conformance to regulations. Discussion questions. How should organizations communicate security risks to non-technical stakeholders and board members? What are the limitations of quantitative risk assessment methods? And when is qualitative assessment more appropriate? How effective is cyber insurance as a risk transfer mechanism? And what are its limitations? Thank you for your attention. Are there any questions? Review questions. Describe the risk management lifecycle and explain why it is a continuous process. Compare qualitative and quantitative risk assessment methodologies. What are the advantages of each? Explain the FAIR model for risk analysis. How does it differ from traditional approaches? Describe the STRIDE threat modeling framework and explain when it should be applied. What is the difference between vulnerability assessment and penetration testing? List the 4 risk treatment options and provide an example scenario for each. How does ISO 27005 integrate with ISO 27001 for information security management? What are the key components of a third-party risk management program? Key terms: ALE, annualized loss expectancy, the expected monetary loss per year from a risk. Asset classification, categorizing assets by sensitivity and criticality to guide protection. Attack tree, a hierarchical diagram modeling the various paths an attacker could take to achieve a goal. CV, common vulnerabilities and exposures, a catalog of known security vulnerabilities. Cyber insurance, insurance covering financial losses from cybersecurity incidents. FAIR, factor analysis of information risk, a quantitative risk analysis framework. ISO 27005, the international standard for information security risk management. KPI, key performance indicator, a measurable value demonstrating how effectively security objectives are achieved. KRI, key risk indicator, a metric used to provide early warning of increasing risk exposure. PASTA, process for attack simulation and threat analysis, a threat modeling methodology. Penetration testing, authorized simulated attacks to evaluate system security. Risk acceptance, acknowledging a risk and choosing not to take action against it. Risk appetite, the level of risk an organization is willing to accept. Risk avoidance, eliminating the activity or condition that creates the risk. Risk mitigation, implementing controls to reduce the likelihood or impact of a risk. Risk tolerance, the specific boundaries of acceptable risk variation from the organization's risk appetite. Risk transfer, shifting risk to a third party through insurance or contracts. STRIDE, a threat modeling framework categorizing threats into 6 types. Third-party risk, security risks originating from vendors, partners, and service providers. Vulnerability assessment, systematic identification and evaluation of security weaknesses. References and further reading: ISO and IEC 27005:2022, Information Security Risk Management. NSD SP 800-30 Rev 1, Guide for Conducting Risk Assessments. NSD SP 800-37 Rev 2, Risk Management Framework. FAIR Institute, Factor Analysis of Information Risk. OWASP, Threat Modeling. MITRE Attack Framework. CISA SSVC, Stakeholder-Specific Vulnerability Categorization. IBM Cost of a Data Breach Report 2024. Verizon Data Breach Investigations Report 2025. NISA Threat Landscape Report 2024.